professor, physician, epidemiologist. I am Dr. Shree Banerjee. Hello, everyone. This is Dr. B, and today in this video, I will show you all of the expectations for the discussion and assignment, and also go over some of the basic tenets of multiple regression. Before I get started, though, I want to make a note about the terminology. Multiple regression refers to any statistical test where there is a dependent variable which is continuous and there are more than one independent variables. So at the very least, there has to be a dependent variable that's linear and multiple independent variables. Once you know that your research question is of this nature, then one of the most powerful ways to understand if there is a relationship is by running the multiple regression test. Now, in this lecture, I intentionally used the word linear regression to emphasize the fact that the dependent variable is continuous. So let's keep going here. And when you're going over the research question and the null hypothesis, it's very important to make sure you know what the null hypothesis actually is. Once you clearly state that null hypothesis, then when you look at the p-value and you either reject the null hypothesis or fail to reject the null hypothesis, then the reader will know specifically what that null hypothesis was that you actually chose to reject. So once you have written out your null hypothesis, the next step is to do some diagnostics to determine and make sure that all of the assumptions are actually met. So in previous weeks, you had a list of assumptions that you had to make sure and test for, and make sure that you ran a different test. For instance, in one-way ANOVA, what you had to do is see from a Levene's test, check for homogeneity of variance, and accordingly run a different post hoc test. So you have many of these same types of scenarios take place for multiple regression as well. So we'll be going over the diagnostics. We'll be going over a little bit of the theoretical foundation, and then we can just briefly apply this, not necessarily in that order. So for starters, what are the main diagnostics that are important to make note of? Well, linearity at the very least. I mean, you want to see that the main dependent variable and the independent variable actually has a linear relationship, and is not able to be mapped out using some other sort of relationship. So that's very important. Homoscedasticity. Now that's a very difficult word, but the definition is actually not as difficult. So what homoscedasticity means that the variance of residual is the same for any value of x. So there is not some sort of pattern going on or something in the noise portion. So when you're looking at a model, there is the signal of the model, and then there's the noise or the error that's going on. So if there is some sort of pattern in that noise, then then that is something that you have to be aware of. The other part is independence, which is observations are independent of each other. Normality, which is something that you could use maybe a QQ plot or something to observe and make sure you have normality. And then multicollinearity. Now, multicollinearity is an interesting and important concept, which I will go over in the next slide. So, homoscedasticity, first of all, going back to that, what you do is you plot the predicted values and residuals on a scatter plot, and then you try to determine if you have some sort of cone or fan shape in your data, then you know that this is being violated. So you don't want to see any sort of patterning there. And then multicollinearity, what that is that you have too much of a relationship going on between your independent variables. So you want to test this using the variance inflation factor. And SPSS has wonderful capabilities to do that. And you want to make sure that your predictor variables are not too linked with each other. And this is extremely important because a lot of times when you're running multiple regression, you're trying to control for confounding variables. So if the manipulation of one variable is one of your predictor variables is causing too much of a variation in another predictor variable, you cannot sufficiently control for specific confounding variables as you would want to. So where is the menu in SPSS located where you run the not only the regression coefficients but the collinearity diagnostics? Well, if you look on the left-hand side, this is where you put a checkbox under the different types of tests. And then on the right-hand side, the plots that you want. These are the plots on the right-hand side that are extremely important for you to look at. Okay, so now that we've gone over an application of diagnostics and the foundation and fundamentals of multiple regression, let's develop a little bit the conceptual framework and the theory that guides linear regression, or more specifically, multiple regression. So, first step that I wanted to show you here is the prediction of y from x. So, say, for instance, we created a completely horizontal model. And in this situation, it's a very simple straight line. So you have an actual, the dots represent the actual observations of x and y, and then the line represents the predicted values of x and y. And we're not really using a reasonable estimate as a predicted line. We're actually using just a simple horizontal line to begin with. And you'll see why we did that. So here, right now, what we're doing is we're trying to figure out how far off our actual observations are from the predicted observations. And we're looking for the differences. So the y difference. So yi minus y. So actual versus predicted. And if you can see, and then we're squaring it. So it's actually a sum of all the squares. And you come up with a value when you sum all the squares of the differences. Now, let's hypothetically create a better fit line. And for that, you'll have a certain number of corresponding sum of squares. So this is what's going on here. So this is minimizing the least sum of squares here. So what I mean by that is that we're going to draw a line such that the sum of squares is the lowest number out of all of them, out of all the different sum of squares. So when you do that, and this is why it's called a least squares regression as well, when you do that, then you don't have as much prediction error. And so we want to use the best fit model. So here, as you can see, if you don't use regression, then initially we started off with the 41.2 overall sum of squares. But if you use the least squares regression methods, then that sum of squares reduces to 13.8, which is not bad, which is pretty good. So the total reduction, what is the total reduction? It's 27.4. So then we can calculate the reduction in prediction error. So we just figured out that in this way we can reduce the prediction error by 66.6%. So that is considered your R squared value, or the coefficient of determination. So again, R squared is a value that tells us what percentage of the prediction error in the Y is eliminated when we use the least squares regression on the X variable. So this is again called the coefficient of determination. And it's pretty remarkable that just by simply squaring R gives us such a measurement. So this is drawing from the same sort of F statistic that we saw in ANOVA. And basically the statistic is, the F statistics for linear regression is similar to the concept of the F statistic in ANOVA. It's a ratio of the model mean square and the residual mean square. So the model sum of square is also equal to the total sum of squares. So there's a lot of different calculations here, and if you would like, you can go into further detail as to understanding where some of these equations are coming from. But I've just left this for you for personal enrichment if you want to understand this further. So what did we go over in this lecture? First, we went over how to set up your null hypothesis and your research question, and base this upon the fundamental assumptions of multiple regression. Then we developed this a little further and went over the 5 assumptions that you would want to check for before you go in and run your actual statistical test. Then I showed you in SPSS where to select and find the different menu options to run the diagnostics. And then we went over some of the conceptual framework of where linear regression stems from. There's a lot of concepts involved. There's a lot more aspects to take into consideration when you're thinking about multiple regression. Please go through this video again if you are confused about certain areas, and then go ahead and run your own statistical test from the data sets that have been provided this week. If you have any questions, please do not hesitate to contact me. Thank you.